Okay, so here we go. Last 6 questions. Number 7, we're gonna have to FOIL out that first part, distribute the next part, then combine all the like terms, and then use the quadratic formula. So let's just start on it. So number 7, we have m plus 4 times 4m subtract 2 equals 5 times m plus 3 subtract 10. So let's start FOILing. So we'd have 4m squared subtract 2m plus 16m subtract 8 equals 5m plus 15 subtract 10. Combine our like terms on the same side. So I have 4m squared plus 14m subtract 8 equals 5m plus 5. Now then I'm going to move these terms over to their corresponding terms. So I have 4m squared plus 9m, 9, 10, and negative 8 subtract 5 would be 13. And it now equals 0. So now then we can get our A, B, and our C. Our A is 4, our B is 9, and our C is negative 13. So a negative B plus or minus the square root of B squared subtract 4 times A times C all over 2A. So negative 9 plus or minus the square root of 81 negative times negative plus 4 times 13, 208 all over 8. So we have negative 9 plus or minus the square root of 289 over 8. I'm going to use our calculator. So square root 289 equals 17. Negative 9 plus or minus the square root, or it's not the square root. So negative 9 plus or minus 17 over 8. So we're going to break this up. So I'd have a negative 9 plus 17 divided by 8, and a negative 9 subtract 17 divided by 8. So this one would be 8 divided by 8, which is 1. And this one would be negative 26 divided by 8, which would be negative 13 fourths. So our answer would be 1 and negative 13 fourths. Weird answer. There it is. So let's write that down onto this paper. So 1 and negative 13 fourths. Use the discriminant to determine the number and types of solutions of the quadratic equation. Okay. So the discriminant first here. So our quadratic formula, negative b plus or minus the square root of b squared subtract 4ac all over 2a. When they say discriminant, they're talking about just this part. So our discriminant is b subtract 4ac. Okay. And when it equals 0, so if this, how do I want to write this? If it's greater than 0, there's 2 real answers. B squared subtract 4AC is equal to 0. There's 1 real answer. And I can show you all that one because it was this one. This 100 subtract 100 made it 0. The discriminant was 0, so there was 1 real answer. All the other ones we've done, though, was greater than 0, so we've had the 2 real answers. Even that plus and minus, we'd have one that was plus and one that was minus, but it's 2 real answers. But then this B squared subtract 4AC, it's less than 0. It's 2, and what are they calling it? Unreal? Too complex, but not real. Too complex, but not real solution. And this is because there'd be a negative under the square root. So when we have our negative under the square root, we get to the imaginary numbers. So that's why it's not real. It's imaginary. But that's something we cover more in college algebra. So these are our discriminant rules. This is what you have to use on this, and I probably misspelled discriminant as well. So let's see. On this one, you still have to find your A, your B, and your C in each of these. So our A would be 1. We don't have a B because there's not just X. And our C would be -9. So when we do this, we'd have B squared, so 0 squared subtract 4 times A times C. So 0 squared subtract 4 times a -9 would be -36. So that would be a positive. So it'd be 36. 36 is greater than 0, so 2 real. And then you're gonna need this for that. So I hope everybody watches the videos at this point. Okay. Now we're gonna have to have our A, B, and C on this one as well, but to find our A, B, and C, it has to be equal to 0. So we're going to add our 8. So our new equation is 2x squared, or our rearranged equation, plus 8x plus 8 equals 0. So A is 2, B is 8, and C is 8. So B squared subtract 4 times A times C. So 64 subtract 4 times 2 is 8 times 8 is 64. So it'd be 0, so that would be 1 real. 4 A, C. 4 times 2 is 8 times 8. Okay, just checking my math. All right, this one isn't equal to 0, so we're going to have to move our 5x. So I'd have -2x squared plus 5x plus 2. So now A is -2, B is 5, and C is 2. So we have B squared subtract 4 times A times C. So 25 subtract negative times a negative, so plus 8 times 2 is 16. This is going to be a positive number, so it's going to be greater than 0, so it's going to be 2 real. Another discriminant. So we have, I'm going to move this 5 over, so I have -3x squared. Positive 4x subtract 5 equals 0. So A equals -3, B equals 4, and C equals -5. So B squared subtract 4 times A times C. So 16, and there's 3 negatives, so it's still going to be a subtract. So 4 times negative 3 would be negative 12 times negative 5 would be positive 60. This one's going to be a negative number, so it's that less than 0. So it's the two complex but not real numbers. Just remember, it's have this paper when you're doing the last problems in this. All right, there's one more. Use the discriminant to, I'm going to rewrite these on the bottom of this after this so it's with your problems. Okay, so A, B, and C. This one's not wrote in order, so let's just change it. Then it'd be 3x, and then 2 equals 0. So A equals negative 4, B equals negative 3, and C equals 2. So B squared, negative 3 squared, subtract 4 times A times C. So 9, 4 times 4 would be negative times negative, would be 16 times 2 is 32. It's positive, so it's greater than 0, so it's 2 real. And I'm going to go ahead and copy the discriminant rules and post this one for you. So if it's B squared, subtract 4AC, it's greater than 0, 2 real solutions.